Good morning, everyone. This is Saidul Hassan from Information Technology University from Pakistan, and I'll be presenting my work with my co-authors, Dr. Naif Radi Al-Johani from King Abdulaziz University, Saudi Arabia, and Ikra Safdar from Information Technology University in Pakistan. So the title of our talk is AI Cognition in Search for Relevant Knowledge from Scholarly Big Data using multi-layer Perceptron and RCNN models. So the motivation of our research actually begins by looking at the exponential growth in scholarly big data these days. The recent stats shows that this Google Scholar has reached to 100 million scholarly publications in their dataset, whereas the Web of Science actually has passed through 40 million publications. Interestingly, the full text databases has also increased. For instance, the archive has reached 1.3 million publications more recently in April 2018. So this essentially gives a lot of motivation and the availability of data resources to information scientists and AI engineers to use the availability of these full text database and enhance the traditional TF-IDF based search engines. For instance, some of the things that you can tap using the full text search engine is looking for the metadata that you can find related to the publications data set. For instance, algorithms that are presented in these publications, and also algorithmic related information such as precision, recall, the type of data sets being used in these publications, figures, tables, or different code snips. So one can tap such metadata information to build more advanced search engine that can provide more relevant publications to user that are looking for. Some of the state of the arts that have been tapping these kind of advancements. I'm presenting few of them. One of the key work is by Gillies, who is very known in information retrieval and digital library area. They actually produce an automatic knowledge-based construction from scholarly document and unsupervised system for information extraction that does not require training. Rather, it actually uses entity identification using a graph taxonomy on large data sets. So this is one of the work that is worth seeing. More recent advancement using machine learning approaches is an algorithm seed, which is an algorithm search engine and uses algorithmic metadata to detect an algorithm from scholarly full text. This work has been published in IEEE transaction on big data. And also another relevant work is a figure seed, which extract actually the results in the figures and extract information from the figures from scholarly big data. So some of the three main contributions in our research work is actually the improvement of machine learning based approach that enhances the accuracy of existing state-of-the-art algorithm seed by using multi-layer Perceptron engine. And the second contribution is actually an evaluation metric detection approach that extract evaluation text from the full text publication in terms of algorithmic efficiency like precision, recall, F-measure using our deep learning model. And last but not the least, the third contribution is a prototype development of an AI-enabled search engine that implements the functionality of our proposed approaches. So let me begin with the first contribution that we have in this work is the improvement of pseudocode machine learning based approach. So we actually detect a pseudocode from full text. So the process begins from a typical PDF file conversion to textual information. And there, in order to identify a given pseudocode, as you can see on your slide, we actually choose 15 handcrafted features and the details of those features would be follow up in upcoming material. So from those handcrafted features, we build a feature vector and feed that feature vector to our feed-forward neural network. And there, based on these feature identification, the neural network would decide either this part of that full text is actually a pseudocode or not. Let me quickly give you a review on some of the features that we use. These 15 features for classification, 4 of them are actually the content-based feature, such as the pseudocode keyword, pseudocode symbols, word sparsity, or the character sparsity, etc. 4 style-based features, such as any Greek characters that are found in that line, any comment sign, any functions being used, or if the sentence beginning with a number or not. 6 font style-based features, such as font size, variance in the font size or the font style, average indentation of first 4 characters. This is what we found one of the features that can actually classify between a simple text or an algorithmic one. And last but not the least, we find that this for one context-based feature, which is if it's a algorithmic caption exists or not. So using the data set of 256 papers taken from the original paper of algorithm C presented in IEEE transaction on big data, we use that data set, the same data set, that actually this 256 papers contain 282 unique algorithms in it, because some of the papers may contain more than one algorithm. So we use their data set and their baseline, and the baseline method here in our result section is the method that they deployed, using actually more than 47 features, and compared to our 15 features, we reach more recall as compared to the baseline method, which is 96% compared to 67, and then Perceptron reaches to 97% compared to 87 reported by the algorithm seed folks, and the F1 overall F1 measure reaches up to 96%. So overall, our first contribution improves the classification performance used by the algorithm seed method by 27%. The second contribution in this paper is actually the evaluation metric detection. Previously, some of the state-of-the-art techniques being used using bag of word, bag of n-gram, or LDA methods, but they lack to capture the semantic and the word sequence of the text, and we believe this is one of the most important features to be captured when we are trying to detect the algorithmic metadata related discussion in our full text. So what we use is to tap the power of sentiments and its word sequence that we believe are essential by using our RCNN based model. The proposed solution typically converts PDF files, convert it into text files, and then we also have we do the document segmentations because we believe that such algorithmic related discussion, there is more chance to have this discussion appear in result or methodology, maybe the evaluation section, as compared to the background or introduction section. So we do the document segmentation. So standard pre-processing techniques are applied, and then the text is actually feed to our RCNN model, which would actually check its right or left embedding, give that input to the max pooling function, and the FC layer is then deployed to detect either this algorithmic line exist or not. I will give you the detail of this RCNN model in the subsequent slide. For instance, this RCNN model first of all would pick up a word and try to see its left context or right context. As you see the first word algorithm, so this RCNN model would at the first step would check what is before and what is after that word, and then this input would be given to this yi function, which would fit the non-linearity of this model and then Further, the max pooling function would actually extract the most prominent features out of that. And finally, the soft max activation function is there to fetch to determine the highest probability for that sentence that could be mapped as one of the sentences that is related to algorithm discussion or not. Our experiment shows on 100 epochs that after 30 epochs the model will try to converge and reaches up to 76% accuracy, which we believe is important, and this accuracy is actually much better than the baseline that is simple keyword based approach in order to detect the evaluation matrices from full text data. The last contribution is foremost the important one is the deployment of our models on a real-time data set. So we have two case studies. So one case study actually splits the data into 70 and 30, and the main contribution here is that the conventional TF-IDF search engine just tokenizes and indexes this information, and the search engine would show the results to end user. However, there we add a layer. When we could create a synopsis from the full text, we actually inject those algorithmic related metadata lines in that synopsis, so that the synopsis of that or the summary of that full text paper becomes more enriched, and it has more text related to algorithmic metadata, so that when users search, the queries could be matched against those index terms that are coming from this EMD enabled or embedded metadata. And another important feature in this case study is the deployment of this pseudocode detection. So user can actually then straight away, so first the user can search for the paper, and then the system can take that user to straight away to the part of the paper where the algorithm has been proposed. So for instance, we deployed this case study on conventional TF-IDF based search engine and also AI enabled search engine, and the query in place was deterministic majority voting algorithm with high precision and less complexity. This was the query in place, and for that very query, the conventional term TF-IDF based system actually showed the paper at the 13th rank on the dataset, but on the same dataset, this particular paper actually appeared as a topmost first result. So this was very encouraging. We also deployed in a case study, second case study, our algorithms, a set of algorithms on rather more large data set of more than 21,000 publications of ACL computational linguistic, and there we, against a set of queries, we always found, for instance, query number 1 is about the breadth first search algorithm using direct data set with high precision and recall. So such queries would return our results as the topmost result compared to the traditional TF-IDF based system. So overall, the prototype suggests that this modeling technique is very effective and it can improve the search engine results. So I would like to conclude my presentation here. So we have improved the classification accuracy of existing state-of-the-art algorithm SEER model by 27%. The second contribution, we have also employed the word embedding using RCNN, which can effectively fetch algorithmic related metadata lines, and this approach is helping us to improve the existing search engine implementation. And we also deploy a case study to design an enhanced search engine that improves the searching capabilities over traditional search engines. Our future work seeks to employ natural language processing and machine learning approaches to extract numeric representation of algorithmic performance, because so far this all information is like the textual string representation, but we don't have the capability to understand the float notations or the numeric notations so far. We also believe that the proposed model is a significant contribution to investigate the possibility to extract other algorithmic specific metadata such as runtime, complexity, other input-output variables, or compatible data structures. We also believe that this is one of the few steps towards bibliometric enhanced information retrieval, where the AI engineers, information scientists, and people working in the domain of cognitive computing are, pursuing to have systems being developed where you can have better responses given to users based on their interest and queries. Thank you so much for your time and patience. Unfortunately, I was not able to physically come and meet you guys in person due to delays in my visa. But I can be reached out at this email address, and I would also encourage you guys to visit our lab's website, which is www.slab.itu.edu.pk. Thank you so much.